All right, guys, so we are going to pick up with the next section, segment lengths in circles. And we'll go through the notes and a couple quick examples. The nice thing here is that there's only three different kinds of questions. So if you recognize which question, match that with the notes page, very easy to process. So we're talking about the length of different kinds of segments in circles. So what are the kinds of segments that we have? Well, we have let's get a circle up here. So we have things like chords, we have secants, and of course we have tangents. So those are the three different kinds of um, segment measurements that we're going to be working with. So let's see as we go into some of our notes. So this is all about the parts that we're working with. So here we're working with two chords. So notice that the two chords were both split into two smaller parts. Now we're not saying bisected, but they are split into two smaller parts. So for example, we have the part marked labeled AE and the part EB. Well, notice in the formula, we're just going to multiply those together. And we're going to do the same thing for the others. DE and EC. We're going to multiply those together. So in our first rule, when we're dealing with two chords, we're going to take the two parts of the first one, multiply them together, and that equals the two parts of the second one multiplied together. So not an overwhelming thing. We just got to know what we're dealing with. We're dealing with chords in this case. Let's look at another example here. So we have our segment lengths in circles again. We're working with secants. So again, let's notice what's happening here. In a secant, we have part on the outside, part on the inside. So in this case, we have a secant that only extends outside the circle on one side. Okay, so looking at the secant EB, we're talking about the part called EA, and then the chord is on the inside. Notice our formula. We're going to take the part on the outside, and then we're going to multiply it by the whole thing, EB. So if we had 5 on the outside, 10 on the inside, it would be 5 times 15. So again, think about that. Think about the way this is set up for a secant. The part on the outside times the whole thing. And then on the second, we're going to do the same idea. So we have on the first one, we have EA and times EB. And then on the second one, we're going to do EC, the piece on the outside, times ED, the entire thing. So again, I color-coded the picture to the formula. Secant, part on the outside times the whole thing. And then on the other secant, the part on the outside times the whole thing. So now we look at an example that uses tangents. So with a tangent, the entire thing is on the outside. Well, we're just going to square it. So there's nothing crazy. EA is the tangent. We're just going to do EA times EA. So EA times EA, which is really just EA squared. And then for the other piece, the secant, we're going to do the same thing we did in the previous. We're going to do the part on the outside, EC, times the whole thing, ED, and that's it. So whenever we're working with the chord, we're going to multiply the two parts of the chords. If we're working with the secant, we're going to do the outside times the whole thing. And if we're working with a tangent, we're going to take the tangent squared. So the outside times the outside. That's it. Okay, and that's as extensive as these examples are. So let's just try a few and see where we stand here. So in our first problem, hold on. In our first problem right here, we have chords. So we're going to do the part of the chord times the other part. So for example, we're going to say 4 times x, and that equals 3 times 10. And of course, we're going to solve for x from there. And I'm going to leave that for you. In number 2, we have secants. So remember, with our secant, we do the outside times the whole thing. So we have to take 3 plus x. And again, the outside times the whole thing, 4 plus 2 in this case. So now as we do our work, we just want to be careful, make sure we do our distribution. So we have 9 plus 3x, and that equals 4 times 6 for 24. Okay, so we have to be careful here. And I'm going to leave you to finish that up and find x. Okay. Let's look at our third example, in which we have a secant and a tangent. So for the tangent, we're going to take our tangent and multiply it by itself. So 24 times 24. And then the other one is a secant, so it's 16 times, again, the whole thing, so x plus 16. So just be careful here that you make sure you do the outside times the whole thing. And again, I'm going to leave that for you to do the algebra and work that out. Okay. You can certainly finish it up from there. Now, one other thing I do want to show you, and I'll just slide down a little bit here, is, for example, and I'm not going to do an entire problem, but just a quick example here. So let's say we have a tangent, and that tangent says x plus 5. Well, our rule says take the tangent and square it, right? X plus 5 times itself. In the last question, we did 24 times 24. We're now doing x plus 5 times x plus 5. So remember here, remember FOIL. So make sure that you're multiplying things out correctly. So we have x squared plus 5x. And then for the second half of it, we're going to distribute the 5. And we have another 5x plus 25. Now, we've had to do this off and on throughout the year, so you are accountable for being able to do some polynomial distribution. And in this case, we get x squared plus 10x plus 25. So again, I used a tangent as an example, but this could have been two chords, or a chord, the two parts of it, x plus 5 times x plus 3. Or it could have been the secant, where the outside is x and the inside is x plus 5. Or the outside is x plus 2 and the inside is x plus 5. So I'm just reminding you of how to do polynomial distribution. Okay, so this is really important that you recall how to do this. We've been doing it throughout the year on and off. We haven't done factoring in a lot of things with quadratics, but we have done multiplication and foiling. So you're definitely going to see some problems that require this. All right, that's really the end of the lesson. Do the practice problems and we'll go from there.